Hello my friends and welcome to this quick revision in your favorite subject, chemistry. Today my friends we are going to finish talking about the monoatomic ions and we will answer this question: why do some atoms become cations while others become ions once and for all? Allow me before I answer this question to give you a quick revision, and before this revision I would like to mention a very small piece of advice. Before you start watching this video, my friends, please try to go back to class number 7, part 1 and part 2 and understand it very well for better understanding for this class. Now, my friends, let's start our revision. In the previous classes, we have talked about the atomic structure and we said that an atom is made up of two main parts. The first one is called the nucleus, inside which we can find two types of nucleons. The first one is called the positive protons. The other is called the neutral neutrons, while the second part or the second main part is called the electronic shells or the energy level, among which the negative electrons are distributed. And then, friends, we said that an atom is neutrally charged, which means that the number of positive protons inside the nucleus is equal to the number of negative electrons in the electronic shells. Then, my friends, we said that a monoatomic ion is an atom that either has lost one or more electrons, and in this case the number of protons is going to be higher than the number of electrons, which means that the positive charge is going to be higher than the negative charge. In this case, the atom is going to be transferred into a positively charged ion, or we called it a cation. The second option, my friend, is that this atom has gained one or more electrons, and in this case the number of electrons or the negative charge is going to be higher than the number of positive protons or the positive charge in the atom. In this case, the atom is going to be changed into an ion, and this ion is negatively charged, or we called it an anion. Then, my friends, we talked about the electronic shells or the energy levels, and we said that we have two main types of these levels. The first one is called the main shells. Shell number 1 is K, shell number 2 L, shell number 3 M, shell number 4 N, and shell number 4 5 O. Then, my friends, we talked about the subshells, and we said that inside each of these main shells we have subshells. For example, K has only one subshell which can take 2 electrons, and inside L we have two types of subshells, S and P. As you know, the capacity of L is 8 electrons, 2 electrons for S, 6 electrons for P, so it's 8. For the third shell or the third main shell, we have 3 types of subshells, S, P, and D, and all of them should take 18 electrons only, 2 for S, 6 for P, and 10 for D. And then N, we have 4 types, S, P, D, F, and 4. And for the fifth shell, my friends, oxygen, we have 5 types of subshells, S, P, D, F, and G, and it takes 50 electrons distributed on the subshells. Today, my friends, we are going to answer this question: why do some atoms become cations while others become anions, depending on the electronic configuration we have taken in class 7, part 1 and part 2. Let's start with the electronic configuration of some elements. Here, my friend, I would like to answer the first part of the question: why some atoms become cations, and why some atoms or why some cations become +1 while others +2 while others +3. Allow me to start with sodium. Here sodium has 11 electrons, and we distribute them on the subshells. Here we have 1s, takes 2 electrons. We have 2s, 2p, we have 8 electrons for the second shell. Now they become 10. We still have 1 electron to be distributed, and it is here in 3s. Now, my friend, what is the valence shell of sodium? Well, the valence shell is the third shell. According to the definition, the valence shell is the last shell of the atom that is filled with at least one electron. This is here the last shell, or number 3, which is KLM. And how many electrons can you find in the last shell? We have only one electron. Let's take potassium. Potassium has 19 electrons. We distribute them as we know. Here we start with 1s, 2 electrons, 2s, 2p, 8 electrons, because here for the third shell here we have 3s, 3p, and 3d. And here, my friends, I haven't written 3d because, as I told you before, we fill 4s before 3d, because 4s has lower energy. Here we have 2 electrons, and 8, 10. We have here 6 and 8, 2 electrons, 8 and 18. Here we still have 1 electron, and it is in 4s. So the last shell, or the valence shell of potassium here, is the fourth shell, which is N, and inside this shell we can find only 1 electron. And so the valence shell of sodium is shell M, and inside it there is 1 electron only, and the valence shell of potassium is 4, shell N, and inside it there is also 1 electron only. Now, my friends, according to the octet rule, all the atoms tend to have their last shell filled with electrons like the nearest noble gas to them. In here, my friends, as you see, for potassium and sodium, the last shell has 1 electron only. For sodium, for example, we have 2 options. The first option is that sodium will gain 7 electrons, 1 here and 6 here, so that the shell is going to be, the last shell is going to be filled, or the valence shell is going to be filled, which makes it -7. And this, my friend, this option is a little bit difficult because it needs a lot of energy. Or the other option is that the sodium loses the electron here, and the subshell here, my friend, is going to be transferred from M to L, because the third shell is going to be empty. And as you know, if the shell is empty, we don't need it, we don't count it. So, my friends, the sodium lost 1 electron and it has become +1, as you see. For potassium, potassium has the same 2 options, either to gain 7 electrons to fill the valence shell, which is N, or to lose this electron to become potassium +1. And in this case, my friend, the valence shell, after losing this electron, is going to be the third shell, or shell M. And in this case, as you see here, potassium +1. And as you see, my friends, both potassium and sodium have 1 electron each in the last shell. When they lose it, they become positively charged +1. We carry on, my friends, with magnesium and calcium. As you see here, magnesium has 12 electrons, 2s, 1s, 2 electrons, 2s, 2 electrons. We have 4 here. 6 for 2p, we have 10 electrons. We still have 2 electrons. We fill them with the 3s. So the valence shell of magnesium is shell number 3, and inside it we can find only 2 electrons. Again, my friends, we have calcium here. For calcium, we have 20 electrons, 1s2, 2s2, 2p6. We have here 10 electrons, and because first shell take 2 electrons, second shell L take 8 electrons, 10. We still have 10 electrons. I give here 2 electrons, or this 2s, and 3p, 6 electrons. Here we have now 18. I still have 3D. Again, my friends, we start filling 4s before 3D. And I have 2 electrons. I put them into 4s. And 3D has no electrons to be filled with. That's why I haven't written 3D. And the last shell, or the valence shell of calcium here, is the 4th shell, N, inside which we can find only 2 electrons. Again, my friends, we have the valence shell of magnesium is the 3rd shell, M, while the valence shell of calcium is the 4th shell, N, and each one has 2 electrons in its valence shell. In here, in the case of magnesium and calcium, we have 2 options. The first one is that magnesium can gain 6 electrons and becomes -6, and calcium the same, gains 6 electrons, so that it will, calcium -6 according to the octet rule, because as you know, all atoms tend to have their final shell or valence shell filled full with electrons. And this option, my friend, is out of the question and out of the table, because, my friend, it needs a lot of energy. So the other option here, that both magnesium and calcium lose those 2 electrons here and here, so that the valence shell is not going to be the 3rd shell anymore for magnesium. It's going to be 2nd shell, which is L, and magnesium will have the charge +2 because it lost 2 electrons, while for the calcium, as you know, before, the last shell or the valence shell was the 4th shell, and now it is the 3rd shell, M, and it is calcium +2 because it has lost 2 electrons. As you see, my friends, here, so far, the valence shell of the atom, the normal atom of the element, is different from the valence shell of the ion. Here for aluminum, my friends, we have the same problem. We have 3 electrons in the last shell of aluminum and gallium. Again, the valence shell of aluminum, when it is an atom, normal atom, neutral atom, the valence shell is the 3rd shell, M, and it has 3 electrons, while for gallium, we have the last shell, 4th shell, N, and it has also 3 electrons. Again, my friends, the octet rule, according to the octet rule, aluminum and gallium prefer to have their valence shell filled with electrons, so that they have two options. The first one is to gain 5 electrons to become -5 or each, or the second option, my friends, is to lose their 3 electrons in the last shell here, and they have a new valence shell and +3 charge, both of them here, gallium +3. So the new valence shell of gallium is going to be the 3rd shell, M, after it was the 4th shell when it wasn't a neutral atom, while for aluminum, the last shell is going to be L for the cation, while it was the 3rd shell when it was a normal atom. For the atoms that prefer to be anions, my friend, I take oxygen, sulfur, fluorine, and chlorine. I start with oxygen, which has 8 electrons in the shells. Well, I distribute them according to this electronic configuration. I add 2 electrons for 1s, 2 electrons for 2s, 4 electrons for 2p, and as I told you, my friends, before, try to add those electrons to one another. 4, 2, 6, and 2, 8. We have the same number here. We have 4, 2, 6. With 6 to 12, 2 electrons, 14, and 2, 16, so that you can check that your electronic configuration is correct. Now, my friends, as you see here, the last shell or the valence shell of oxygen is the second shell, which is L, and contains 6 electrons only, and for sulfur, also the last shell or the valence shell is the third shell, which is M, and it also includes 6 electrons. According to the octet rule, my friend, an atom prefers to have its last shell or valence shell filled with electrons. So oxygen and sulfur have two options. The first one is to lose 6 electrons each. For example, oxygen will be plus 6, or to gain 2 electrons, which is easier for them. That's why oxygen will be negatively charged, because it gained 2 electrons. In the previous cases, those atoms lost electrons. That's why they became positively charged. In these cases here, we have negative charges because the atoms are gaining electrons. For the final case, my friends, we have a fluorine and a chlorine. Again, my friends, the last shell of each has 7 electrons. This is the last shell, L in the case of fluorine and M in the case of chlorine. Each one has 7 electrons, so they prefer to gain 1 electron only. Fluorine going to be minus and chlorine going to be -1. After this explanation, my friend, I think that everything has become clearer and easier for us, and now we can say why some atoms become cations and why some atoms become anions, why some cations becomes +1 charged while others become +2, others become +3. For the anion, why some of them becomes -1 and why the others become -2. That's it for today, my friends. I hope you enjoyed this class and you learned something from it. In case you didn't understand the point, please try to replay this video again or play some Kahoot games which are related to this topic. In the next classes, my friends, we are going to start talking about making a chemical compound together using monoatomic and polyatomic ions, and we will learn, my friends, how to organize these ions in a special chart made by me. I hope you will enjoy watching these videos, and you will learn how to make a chemical compound or an inorganic chemical compound together. Thank you, my friends, and I wish you all the best.